Okay, so a block of mass 0.250 kilograms is placed on top of a light vertical spring of force constant 5,000 newton meters and pushed downward so that the spring is compressed by 0.1 meters. After the block is released from rest, it travels upward, then leaves the spring. To what maximum height above the point of release does it rise? Okay, so the first thing that we have to note is the height that the spring is compressed. So that is, let's just say this distance from here to here, and we're going to call that x. So, since we're talking about conservation of energy, the energy at the top of the rise right here is going to be the same that is stored in the spring when it's compressed. So that means that mgh, which is gravitational potential energy, which is present up here, is going to be the same as 1/2 kx squared, where k is the spring constant, 5,000, and x is this distance down here, which is 0.1 meters. So we place the all the values into here. So the m is 0.250, gravity we'll use 9.81, times the height, which is what we're trying to solve for, and that equals 1/2 k, which is 5,000, and then x squared, which is 0.1 squared. So to do this, we are going to divide everything to the other side. So we have 1,000, or 1/2 times 5,000 times 0.1 squared divided by 0.250 times 9.81, and that's going to equal the height. And so if we calculate this, we're going to get h equals 10.194 meters. And that's the answer to that question. So, and that is question number 1 on the study guide. Over here we have question number 6. This question is a power question. It says, an 820 Newton Marine in basic training climbs a 12-meter vertical rope at a constant speed in 8 seconds. What is his power output? So we know that power equals the force times the velocity times the cosine theta. The force that he is applying is 820 newtons times the velocity, and velocity is position over time. So his position is 12 and his time is 8. And then the cosine theta, that's just going to be 1 because he's traveling upward, and the direction of the force is the same direction as where the motion is. So that would be cosine of 0 would just be 1. And so if we type all this into our calculator, we get that the power is equal to 1,230 watts.